Hello and welcome to the first ever video of this channel. I am a full stack Python dev and today I will walk you through the creation of a RAG-based query system. Here we see the end result. This is the front end part of the system. This is the response that we received. These are the sources that were used to construct this response, and this is the form where we can ask our question, select the document where to get the answer from, and the number of sources that we'll be using to answer our question. So let's get straight to the nitty-gritty. Before we start, this is a RAG system built with Flask and Python. And to get it going, let's talk about why we should bother with RAG system in the first place. Let's talk about the purpose of it. RAG helps smart AI tools give better answers by checking real facts. It makes them tell the truth more and make up less information. How it does this is, RAG works by looking up real information before answering. This way, the AI doesn't guess, it uses facts to help answer questions. However, we are faced with two problems here. We need to make sure the parts of RAG work well together, and it has to find the right facts. So this translates into a problem with integration and a problem with retrieval accuracy. RAG has two big parts, finding facts and writing answers. Putting them together the right way takes a lot of skill, so there's a bit of a learning curve. For retrieval accuracy, RAG must find the best info. Not too little, not too much. If it gets the wrong info, the answer can be wrong too. So today with this system, we will be tackling these two problems. Now, let's take a look at a diagram for our system. The first part of the system is to prepare a specific document for RAG processing. So here we upload, say, a PDF to be processed through a Flask form. Then this PDF is saved temporarily. It is then processed and read as text by a PDF reader library. Then this text in the PDF is split into chunks of text. These chunks are then sent to OpenAI API, which generates an embedding vector for each chunk. These embedding vectors are then saved and stored in a vector database. In our system, we are using ChromaDB. So the ChromaDB is then saved to file system where it will have to remain so the system can function properly. Once this is done, we are ready then to ask questions about our document and get answers with sources. Here we ask a question through a form. We specify the document that we want to get the answer from, and of course we type our question. These two are bundled up and sent to OpenAI API. Here, the API translates the user question to an embedding vector, and then it uses that vector to search the vector database we already created to find all matching chunks. These matching chunks are then sent to an LLM, say here we are still using OpenAI, and then the LLM is instructed to answer the question from the matching chunks. And then once we have the answer, we show it on the front end with sources. Alright, now let's take a look at a live demonstration of this system. This is the first setup form, the RAG database creation form. In this first field, we just input the name of the file we'll be processing. In this case, it's Introduction to Business. Here, we just add a description of the file. I already have it copied, so I just paste it. And then here, we upload the file itself. In this case, we have a PDF already uploaded. And then we process the file. Now once a document has been processed and a RAG database is created, we get redirected to this form. In here, we can select on the first field of the form the document that we want to get answers from. In our case, we want the Introduction to Business. Here, once we select a document, we get the description that we wrote on the first form. Now we know what the document is about. So in the query, we ask the question that we want to know the answer of. So let's say, how can businesses get and keep clients? Alright, now seeing as this is a general question, we come here and we decide the number of sources we want the system to answer with. In this case, let's choose 5, given this question is a bit broad. All right, let's get our answer. Here we have it. The answer is businesses can get and keep clients by focusing on increasing customer retention rates, blah, 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 blah. It's quite a paragraph to detail the answer. These are the sources that were used to construct that response. Each one of these sources is accompanied by the exact page where it was pulled from. Under the context spoiler here, we can find word for word the text that can be found on the PDF, and this together, all 5 of them, were used to construct this response through the OpenAI LLM. So if we look at a PDF and look at page 60, we will find somewhere that there's this little sentence here. And the same goes for each one of these contexts. And here we can ask another question. So let's try another one. Let's ask what makes a successful and sustainable business? Now, seeing as this is a more broad question, let's get more sources for it. Now we changed it to 8. Let's see what it tells us. Alright, we got an answer already. As you can see here, the response is generated, and this time we have 8 sources, each one from a different page. Alright, now let's take a look at the code. Here we're setting up the heart of our RAG system with this class called RAG database. Here we can only see the init part of the class, but this class has multiple methods that we'll be seeing in the upcoming slides. At the start, we grab a couple of tools from NLTK which will help us understand language. Specifically here we use in English, so we get the English taggers. Then we look for the OpenAI API key and the path to our Chroma database. Both are saved as environmental variables. Then we set up a few variables where we're to save the database, where to find the PDF or the input files, and 2 placeholders. This part is where the magic starts to happen. First Prepare kicks things off by calling the generate data store method. In this method, we load the documents, break them into smaller chunks, and save them into a searchable format. This is the core of how our system learns what's inside the files. Then we have a helper method which adds a description to the database based on the description that we gave to the uploaded file in the form we've seen before. Then the load document method, this one digs into the folder. The folder is defined here, which is a path to where we can find the PDF. This parameter decides what the extension of the target files would be. In this case, we're looking to process PDFs. And then this is the PDF reader from LangChain that we're using to read the PDFs. This step is basically like tagging your files before you organize them. Here, we just make sure that every file has the description added to its metadata so we can tap into it when we need to later. Together, these steps prep your data so it's clean, labeled, and ready to be used by the AI later on. Now, this method, split text, takes in the documents and slices them into smaller pieces or chunks so the AI can understand them better. We use a tool called Recursive Character Splitter, or Recursive Character Text Splitter, which breaks things down into chunks of 300 characters defined by this parameter with a bit of overlap. Just to keep context between chunks, think of it like reading a book with some lines repeated on each page so you don't lose the story. After we print out one of the chunks is a quick check, just to make sure the splitting worked. Finally, we return all the chunks ready for saving and searching. This is an important step so that later when we ask questions, the system knows exactly where to look. Finally, Once all the document chunks are ready, we're ready to save them into the Chroma database. Here we have the maximum number of tokens that will be sent in per batch. This is the number, or rather the maximum number of tokens that OpenAI allows through its API. This is the tokenizer model we'll be using, and this is the name of the model. And here we stored an object from the OpenAI embeddings class. Then here we check if there's already a Chroma database that exists with the same name as the current file that we are processing. If it does, we remove it so we can store a new one. This is to avoid any issues with overwriting or incompatibilities or file corruption. After that, we go chunk for chunk, and then we tokenize each chunk, and then we make sure that each chunk that we get or that we send to OpenAI API is below the max tokens per batch that we already defined. Then we add all the tokens and append them to the list of batches. Once that is done, then we use the first batch to create the Chroma database using the embeddings model and in the Chroma path that we have defined. Once that is done, we then add every subsequent batch into the Chroma database that we created. And of course, we print add a bit of login, manual login, to make sure that everything is going smoothly. Now that we have our Chroma database ready, we are ready to start asking questions and getting smart answers. Here we have the RAG query class. This is the class that handles question processing and answer generation. We have, for the init, two variables or parameters that are passed along. The first one is the document name, which is used to find the Chroma database in our file system. And then the number of contexts is the number of sources that will be used to answer a question. Here we have the prompt. This prompt instructs our AI to answer only from the provided context, and the context is composed from all the text chunks that were deemed relevant by the Chroma database after processing the question. And then, of course, we also provide the question in the prompt, and we also define some important rules for formatting. This makes sure that the answer is a clean, direct HTML formatted answer with no extra notes and no brackets. So we can directly display it on a web page with minimal preparation. Now we're inside the getResponse method, which is the second part of the same class. It starts by preparing the same embedded model that was used to store the data. That way, the query and the documents can be compared on the same basis. Next, it loads the Chroma database using the stored path and performs a similarity search with a relevant score, asking Chroma to return the top matching chunks based on the query. Here, the relevance score is 70%. If the results are good, we then stitch together the text from each relevant document chunk into a single block of context, separated with some formatting. This gives the AI enough information to generate a grounded answer from the context provided. Finally, we plug the query and retrieved context into the prompt template, getting it ready to send to OpenAI. Now the second part of this method is where we see it. Here, when we send it to OpenAI, we use the model GPT-4o Mini. This model is very much adequate for answering questions based on a given context, and it's also very affordable. The call is wrapped in a try block, so we can handle any errors that may arise, such as timeouts or rate limits. So if anything goes wrong, it logs a warning with the errored details and re-raises it. After getting the response, we also collect the metadata for each context chunks, like its source, the page number, the line where it starts, which is called start index, and description. Finally, we return a dictionary with 4 things. It's the AI's response, stored here, the sources, all the sources that we have here, the prompt, and the context. If the Chroma database throws any errors like connection issue, it's caught separately and logged as a ChromaDB error. Any other unexpected exceptions is also caught and logged to make debugging easier. Now let's take a look at the Flask forms. These are the Flask forms that are rendered on the front end to allow us to, this one, upload a PDF file to be processed through RAG. The first thing that we have here is a field for the document name, a string field where we put the title of the document. And then document description, this is a text area field, which is a text box that allows us to write a whole paragraph about what the document is about. This is a file field that allows us to upload a file, and this means that a file to be uploaded is required for the form to process. And here, this one only allows PDF files to be processed. And this is the submit button with a custom class. Now next up, we have the second form. This is the form that allows us to ask questions. The first part of the form is a select field. This one allows us to select the document where we want to get the answer from. The list of options here depends on all the documents that we have processed. So only the documents that are processed and exist in the Chroma database will be displayed here. And then we have the text area field where we can put our question. And then we have the number of sources, which is an integer field. The value of this field here is passed to the backend, which allows us to have a specific number of sources to answer our question. And then here we have the submit field, which is the submit button again to get the RAG answer with a custom class. Alright, now let's take a look at the Flask functions. First of all, we create a form object from the Flask form class that we've seen before, and then we send this object to the HTML template so it can be rendered on the page and become usable on the front end. Then we check for when the submit button is clicked. That's when this condition is checked and the rest of the code is processed. We then get the document name by calling the form, tapping into the document name, and then calling its data. We do the same for document description and the uploaded file. Here, we secure the file name to remove any strange characters that could compromise its handling. Then, we save it temporarily to a folder. Now, we get to create a RAG database. The first part is creating a RAG database object from the RAG database class that we've seen before, and pass the uploaded document and the file type as parameters. Then we call the add manual description method. This method here accepts the document description as a parameter so it can be directly added to the database. And then we call the prepare method here. This one handles reading, splitting, chunking, and database creation. Once all is done, we call a helper function to delete the file from the temp folder, because in production we always want to save space. And then we redirect to the page where we can ask questions and get answers about our document. Now for the Flask function handling the page where we ask questions and get answers with sources. We start with creating a RAG form object from the second RAG form class. Then we set up some placeholder variables. We run the condition check for when the submit button is pressed and then collect the info sent through the form. The document that we'll be using to answer the question is here. This is where we pull the question from, and here is the number of sources we want the answer to be generated from. Then we create a RAG object from the RAG query class, along with the document and the number of sources as parameters. After, we load the result of the method getResponse into a variable. This method takes both the question and the number of sources desired as parameters. If somehow the result is a none type, we fail the process gracefully by showing a simple error message on the front end and redirect the user to the same page to try again. Now, if the result is not a none type, we continue unpacking it in the second part of the code here. We unpack it to different variables. We have the response, containing the AI-generated answer from the sources the system pulled. The sources here contain all the metadata of where in the document the answer is pulled from. In this case, we have the document name and the page for PDFs. The prompt contains the instructions we give to the LLM to answer. This one contains the questions and the text that this question should be answered from. And finally, the context is all the text that had a high enough relevance score to our question according to ChromaDB. The number of text depends on the number of sources we set up in the form. Now, we're in the for loop. Here we will just format the sources to be more readable. As in the raw form, they look like an absolute path. The source initially comes in tuples, and we split it to two. The first element of the tuple contains a path to the document. The second one contains the number of the page where the context is pulled from. Once they are properly formatted, we append them as keys to a dictionary we can unpack in the HTML part of the page. Now let's take a look at use cases for RAG. Uploading a PDF and processing it is not exactly the best use case. Some sectors need correct answers, no guessing allowed. And that's where RAG really helps. The legal sector. Let's say, for example, a use case, helping lawyers find the right laws or court cases. An example of a question that a lawyer could ask a RAG system is, what did the 2015 Supreme Court case say about free speech? RAG looks it up and gives a real answer from the court cases. And then we have healthcare. A use case would be supporting doctors with medical info they can trust. A doctor could ask, what are the new guidelines for treating high blood pressure? RAG finds the answer from trusted medical documents. And then we have company knowledge base. A use case would be answering employee questions using company files, specifically HR-related files. So for example, an employee asks, how do I request travel reimbursements? And then RAG gives the answer from the HR handbook. And there's more to this. RAG is great anywhere people need real facts and where it is more expected to have concrete and reliable answers. And we reached the end of this video. You can try a live demo of this RAG system with some preset documents on my website here. If you're interested in implementing a RAG system tailored to your needs, feel free to reach out by scheduling a call on my website, by the contact page on my website as well, or by just reaching out on LinkedIn. Don't forget to like, subscribe, if you'd like to see more content like this, and leave a comment with your thoughts and questions. Bye bye.